Welcome back. This is going to be our midterm review for Chapter 2. Once again, I have that bit.ly up there for people that are watching that are not in my class. This is going to be dealing with modeling distributions of quantitative data, primarily the normal curve. And it's still going to be falling under Unit 1 in the AP unit schedule. So this is going to be Chapter 2, and Unit 1 covers Chapters 1 and 2. It's a pretty long unit. It's a big chunk of the AP exam. So I'm going to leave some of this information up here if you want to write it down. Once again, I'm not going to go over any of the words on here, but you're welcome to highlight it, take notes, write some additional things on there, or even go back in your textbook and get some additional examples if you need to. Here's our first problem. A group of students were asked to estimate the width of their classroom in feet. Use the dot plot and summary statistics to calculate and interpret the approximate percentile for a student who estimated the classroom width to be 34 feet. So to get a percentile, you want to think of points that are at or below a certain value. So since I'm looking at 34, I want to focus on finding 34 on here and counting all the points that are there and below. You should do that before we move on. So I circled the ones that counted 34 and below. That's going to give me 15 points. You got to divide that out by the total number of people. And where do you get that number? Well, you can count them all, but you don't have to in this case because it's right there. So n is going to be your total number. Just 15 divided by 66 will give you 0.227. Now from there, you're going to want to throw that into a percent. And generally with percentiles, we stick with whole percents. We don't really want to deal with points on those. So what I'm going to say is something like this. Students who estimated a width of 34 feet were in the 23rd percentile. I just rounded up, meaning they estimated a width that was at or higher than 23% of the student estimates. Or another way to say it is 23% of the student estimates were at or below 34 feet. All right, next question. This is question 4. It's going to give you a cumulative relative frequency graph. Relative frequency is just percentages. So Mrs. Causey asked her students how much time they had spent watching television during the previous week. The figure shows a cumulative relative frequency graph of her students' responses. The first question, A, according to the graph, the shortest 60% of time spent watching TV were how many hours per week? So we want to kind of draw on that a little bit. The way that I do it is I go to 60 at the percentage mark and I meet the line. You don't have to be super perfect. Then I go back down to the x-axis and I'm just estimating about 8. It could be 7.5, even closer to 7, but I'm just kind of throwing that out there. So what I ended up saying was the shortest 60% of times were less than about 8 hours per week. And the reason I said less than was because it says the shortest. So the shortest 60% of the times would be all these times, at the 60th percentile and below. So I said less than about 8 hours per week. Letter B, the middle 50% of the times spent watching TV were between what two times? Middle 50% is just another kind of code word for Q1 and Q3. Okay, so Q1 and Q3, think about the 25th and 75th percentiles, if that helps, and see if you can get those values, and then you can unpause it. All right, here's my rough sketch. It's perfect. It's not perfect at any means, but I estimated about 25 percentile to be there, maybe around 3. In the 75th percentile, I don't know, somewhere around 11, I guess. And so I think I said between about 3 and 11 hours. So we're just talking about these right there. Between 3 and 11 hours is the middle 50%. All right, look at the last question. The highest 20% of times, highest 20 is going to be up here, is going to be how many hours? See if you can figure that out. It's still a range, so the highest 20% of times is going to be anything at the 80th percentile or higher, which means that that's going to translate to any of these numbers or more. So I'm looking at anything above, I guess 14, 15, somewhere in that ballpark. We're talking about all these up here. Okay, so that's going to be, these numbers are going to all fall in this highest 20 percentile. So anything from like 14 and a half or 15 all the way until when it cuts off at 30. This is what I wrote. I think I said 15, but if you say 14 or 14 and a half, that's okay. The highest 20% seem to be above 15 hours per week, approximately. All right, let's go on to the next question. All right, in this question, it says Mr. Weisert's first block Math 3 class took a test. The mean of the test was 83 points with a standard deviation of 6 points and a maximum score of 92 points. This question says, based on the relationship between the mean standard deviation and the maximum score, is it reasonable to assume that Mr. Weisert's first block test scores are approximately normal? And you want to think about a drawing of this one. So I would sketch out a normal curve, plot out the standard deviations, count out by 6, and kind of see where 92 falls before you answer this question. Pause the video and try that. Now, your normal curve doesn't have to be super pretty like mine, but I used a computer, so, it is what it is. So you have a normal curve. You can label it N 83,6. That's your mean standard deviation, and just count out by 6s. And look where that 92 falls. That's going to be right here. That's only 1.5 standard deviations above the mean. So there's a lot of data that could be up here that doesn't exist, and if it were normal, you'd need that data. So what I would say in this problem is, since the maximum score is 92, and that's only 1.5 standard deviations above the mean, I'm going to say a normal distribution is not appropriate. Now let's look at letter B. Student A scored 75 points on their test from this class. Calculate and interpret their z-score. Think about what a z-score is. If you need to look it up, please do. All right, a z-score in a distribution is simply how many standard deviations above or below the mean that point is. So it's the value of the point you're looking at minus the mean divided by the standard deviation, which in this case, the value we're looking at is going to be 75. We're going to subtract the mean of 83 and divide by 6. And that's going to get you a negative value. That's going to be negative 8 divided by 6, which ends up being about negative 1.33. What does that mean? For a z-score, that's a negative. I say it's below the mean. So I say a score of 75 is 1.33 standard deviations below the class mean. Letter C is very similar. It wants to know how a score of 73 in a different class compares to this score. So in Mr. Weisert's third block, the class mean for the same test was 76 points with a standard deviation of 5 points. Student B scored 73 points on their test for Mr. Weisert's third block. Which student is better relative to the respective class? Not which student is better overall, because obviously a score of 75 is better than 73, but relative to the people in this class, which is better. That's what we're looking at. You're going to notice also that this class mean was smaller. So when you look at the z-score, think about, you're subtracting a smaller mean. What does that do to the overall z-score? Try subtracting this, get that z-score, divide by the standard deviation. I'll wait. Got it? All right, here you go. 73 minus 76 divided by 6. Oh, mistake. You didn't see that. It was 5, not 6. That standard deviation here is 5. All right, now that's going to be negative 3 divided by 5, which is actually just negative 0.6, which is a smaller z-score, or larger actually. Negative 0.6 is greater than negative 1.33. If you look at a standard deviation, it's going to be it's closer to the mean. So in this case here, what I would say is student B had a higher z-score than A. So they scored better relative to their class. They didn't score better, they scored better relative to the people around them. All right, here's our next question. A laptop manufacturer states that their mean battery life on a full charge of a particular model of laptop is 220 minutes with a standard deviation of 32 minutes. And notice that we're talking about a normal distribution. Well, it actually doesn't specifically say that, but we're gonna assume that in this problem, since we're talking about, actually, it should say that in the problem. So I should have put that on there, did not, oh well. What percent of batteries of this particular model of laptop last more than 4.5 hours? Show your work. So in this question, we really want to know what's the probability X is greater than 270? Where did I get 270? Well, we're talking about minutes and then they throw hours at you. So we're going to have to do a little conversion, right? So 4.5 times 60 is 270. So I want to know the probability that laptop's battery is going to last more than 270. We're going to start with drawing a normal curve. Sketch out a normal curve. And again, you don't have to have all of your labels on all the standard deviations, but I did here just for a reference for visual. So what I'm looking at, a shaded above 270, what's the probability in that area? And we're going to use a normal CDF. So when you go to your calculator, you're going to go to second vars. You press second vars, and you're going to put these values in. Your lower bound is going to be 270. Your upper is going to be something to represent infinity. So 9999999. Your mean being 220, your standard deviation being 32. You want to write those inputs down to get credit. Then you're going to go over here and you're going to get this value when you click paste. And that value is about 0.059. And finally, write a sentence. Use context. So about 5.9% of this laptop manufacturer's batteries last longer than 4.5 hours. Part B. What is the time on a full charge of a battery in the 45th percentile? So the 45th percentile, you're looking at a little bit below the middle of it, so the mean. So somewhere right around there. I want to know, what is that X value? Maybe it's like 210, 205, not really sure. So what I'm going to do in this problem is use an inverse norm. And you're going to do second vars and go to inverse norm. And area in the modern calculators, you can do left, center, and right, but percentile is always going to be to the left of that area. So make sure you select left. 0.45 is going to be your area. Mean and standard deviation will be the same. You're going to get about 215.97. That's going to represent this X value here. And so you'll say, I'm going to round up to 216 because the question wants to know what is the time on a full charge of a battery in the 45th percentile. And I can just say that's about 216 minutes of battery life. All right, finally, the last question. The company will replace batteries that are performing in the bottom 2%. What is the minimum time on a full charge of the battery would have to last for the company not to replace the battery? So they're trying to cheap out. We're trying to find the cutoff at the bottom, right below the bottom 2%. Visually, it's going to look similar. It's going to have this shaded here. And I want to know what's just right above there that the battery company is going to not replace that, or the laptop company is not going to replace that battery. So once again, since I'm giving a percentage, I'm going to utilize the inverse norm. We're going to go into inverse norm and we're going to put in 0.02. You're going to make sure you're going left. The default on calculators is left if it doesn't say so. You're going to get a value of about 154.28. Now that's within the bottom 2%, so I'm going to round up to 155 because we're looking at when they're not going to replace the battery. And they're going to replace the battery here. They're not going to replace the battery in all of these. So what I would say in this problem is battery life at 155 minutes would be the minimum time for the company not to replace it. All right, that concludes this video going over distributions and normal curves. The next video, we'll talk about two variable data, scatter plots, and all that good stuff. Thanks for watching.